there, Mr. Holcomb here again with another episode of Math Behind the Module. Alright, here's lesson 24, percent and rates per 100. Exercise 1. Rob's fruit farm consists of 100 acres, on which 3 different types of apples grow. 100 acres. On 25 acres, the farmer grows Empire apples. Macintosh apples grow on 30% of the farm, and the remaining farm grows Fuji apples, remainder. Okay. Shade in the grid below to represent the portion of the farm each type of apple occupies. Use a different color for each type of apple. Create a key to identify which color represents each type of apple. So I'm going to do the colors that I used here. And I circled or underlined Empire apples in red. So here's my color key. Macintosh. Actually said just draw a line. I'll write the word red. Macintosh green. And Fuji blue. Okay. So we have this grid, and if you count across 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 squares across, and if you count these, there are 10 squares on the side. So that is a grid 10 by 10, so there are 100 squares. So if we're talking percent, the word percent means out of 100. Okay? And so if we have 100 acres total, then each one of these little squares here is an acre. Okay? So just to give you an idea of what's going on here, and oops, that. Okay, so it says to use a different color for each type of apple. Create your key to identify which color represents each type of apple. All right, as long as you color in the right number of squares, there's no wrong way to do this. You can do it vertically, horizontally, whatever. I'm going to start with the given. Empire apples, 25 acres. Since we have 100 acres, that's 25 out of 100, that's 25%. So 25 acres in this case is 25% because we have a total of 100 acres. And each acre is a square, so I want 25 squares for Empire apples in red. So this section here is 10 times 2, which is 20, and then 5 more. 1, 2, 3, 4, 5. Okay. So if I shade in all of this, okay, those are Macintosh apples. I'm sorry, Empire apples. Now we'll do Macintosh in green. Macintosh is 30% of the farm. Okay? So if we do 30%, that's 30 squares. Well, here's 20. Here's 5 right here. So there's 25 if I do this. There's 25 and then 5 more. 30. 10, 25, 30. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Okay, you get the idea? So this is 30%. So the red, Empire, 25%. Green, Macintosh, 30%. And then the remainder is blue. So how many is that? 10, 20, 30, 40 right here. There's 40 plus 1, 2, 3, 4, 5. So let me shade that in. And there's 45. Okay. So there's our shaded regions. So So now we're going to say part to a whole ratio. Well, we had 25 out of 100 empire. We had 30 out of 100. I forgot a zero up here. 30 out of 100 Macintosh. And 30 plus 25 is 55, so we had to have 45 out of 100. So all these numbers add up to 100 out of 100. So there's exercise 1. Okay. Exercise 2. The shaded portion of the grid below represents the portion of a granola bar remaining. What percent does each block of granola bar represent? Well, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 100 squares. So if we remember what this means, this is 10th, and this position is 100th. It means 1 out of 100 is 0.01. So one of these squares, just like in the last example, that is 1 square out of 100, or 1%. So that brings up another key component to this percent thing. 1%, if we want to turn that into a decimal, we would assume the decimal starts right there. It's a whole number 1. To make a percent a decimal, we move the decimal place not 1, but 2 places to the left and put a dot there and get rid of the percent symbol. So these are each 1%, because it's 0.01. Moving the decimal 2 places to the left. Okay? So a shaded portion of the grid below represents a portion of a granola bar remaining. What percent does each block of granola bars represent? What percent? 1%. What percent of the granola bar remains? Well, 1, 2, 3, 4, 5, 6, 7, 8 by 10. This is the remaining. That's 80%. What other way can we represent this percent? 80 out of 100. That's where the 80 100ths comes from. 80 100ths would look like that. Oh, I might as well put it here, because that's what else we're going to call it. Those are the 2 other ways we can represent a percent. 80 out of 100, or 80 100ths as a decimal. Okay? Exercise 3. For each figure shown, represent the gray shaded region as a percent of the whole figure. Write your answer as a decimal fraction or percent. For some reason, I don't know why they did it, but in class this caused confusion. If you look in your module, this here was dark gray, and this was light gray over here. So some students thought that the whole thing shaded was 100%, and I wouldn't say that's wrong. But let's just focus on the dark gray with respect to the light gray, or compared to the light gray. So it says, for each figure shown, representing the gray shaded region as a percent of the whole figure. So let's just focus on this piece here, and that is picture A. That is 20%. Okay. Write your answer as a decimal, 20 100th, as a fraction, 20 over 100. And we've already done it as a percent. Okay? And if we wanted to do that in that order, I guess this would be like this. Okay? Decimal fraction percent, decimal fraction percent. Picture B. Okay, well, this is light gray. This is dark gray. All right, so this is a 5 by 5, which is 10. This is a 5 or 25. This is 5 by 5, which is 25. So this is 5 by 10, which is 50%. Okay. So if we're talking just the shaded region, not dark or light, but shaded all shaded, light and dark combined, then that would be 0.50 as a fraction, or a decimal, I mean. 50 100ths as a fraction, and 50% as a percent. Okay. Alright, now on this one, this is an odd shape. So these are all shaded, and there's 10. These are the only 2 shaded, so that's 2. Then we have all but 2 shaded, so that's 8. And here's 2 more. And then this is 3, 4, 5, 6. And this is 2. These are 4, 2, 2, and then a full row of 10. So if I add those all up, 10, 12, 14, 18, 26, 28, 36, 38, and 10, and 48. 48 out of 100 squares are shaded. That is 48 100ths. That is 48 over 100. And that is 48%. Okay. Okay, and then part B says, what ratio is being modeled in each picture? Well, I could say 20 of the 100 are shaded gray. In the second picture, I could say 50 of the 100 are shaded gray. And in C, I could say 48 of the 100 are shaded gray, something like that. How are the ratios and percentages related? Ratios, how are ratios and percentages related? Well, the ratio is out of 100, and in percents out of 100. So I guess they're that's how they're related. Okay, they're both out of 100. Okay. Next question. Exercise 4. Now they're giving us a relationship, and we want to compare shaded portion to part to the entire figure, the whole, and then complete a table. So we're given a percentage. They want us to make a decimal, a fraction, a ratio, and a model. Okay, so here we go. Remember I said with a decimal, we have to move the decimal 2 places to the left, so that's 6.0. So if I move it 1, it's 0.6. If I move it another, it's 0.6. So that'd be 0.06 or 0.06. So 6% is 0.06. A fraction would be 6 out of 100. The ratio is 6 to 100. And the model, that's a little tricky with this because it might take a little while. The model would look at our last page. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So there's a 10 by 10 grid. There's our model. And we want 6% or 6 squares shaded. There's our model of 6%. Okay? I could have reduced that to 3 out of 50, and then gotten rid of 1, 2, 3, 4, 5 rows. So now this would be my table. Okay. But then I wouldn't want to shade 6 of those. I only want to shade 3, and then get rid of these. It's just another option right there. We can always reduce those, and 3 out of 50 is also going to be 6%. Okay? 3 out of 50 is the same as 6 out of 100. They're equivalent. So that would be 6% as well. 6% of that grid is also shaded. All right, 60%. Remember, move the decimal 2 places. So that's going to be 0.60. And that's going to be 60 out of 100. And that's going to be 60 to 100 as a ratio. And then our model, well, now we're going to do 60%. Well, this one I can just do 1 row of 10 because it reduces down that much. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. okay? And 60% would be 6 out of 10. Reduced, 6 out of 10 is 60% of one row. So there's 6, leaving 4 not shaded. So that's 60%. Rather than drawing a big grid of 100 every time, we can reduce to make it easier. Okay, 600%. Again, remember, there's our decimal. Move it 2 places. Now that's 6.00. So a whole number greater than 1 means we're more than 100%. That's the first time we've seen that. That'd be 600 over 100, which would be 600 to 100. Well, if we picture this, say that's a grid, and if we zoom way in, and this is a grid, 100 by 100, 600% means 100% of this grid is shaded in, and we would have 6 of those grids all shaded in 100%. So 600% would be 6 grids of 100 all shaded. So let's pretend those were all grids all shaded in 100% of them. Okay? That would be 600% separate grids. Okay, 32%. 2 decimal places, 0.32. 32 100ths written as a fraction, and 32 to 100 as a ratio. Okay? And 32 out of 100 again can be reduced, and I would do it at the fraction here, 16 out of 50. You can do it again, 8 out of 25. Okay, 8 out of 25. So I could make a grid of 25. This. Okay, we can always reduce down to whole numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 20. And then 1, 2, 3, 4, 5 to here. There are 25 squares. And 32 over 100 equals 16 over 50 equals 8 out of 35. So I could just shade 1, 2, 3, 4, 5, 6, 7, 8. So I shaded 8 out of 25. And that is 32%. 8 times 4 is 32. 25 times 4 is 100. So 32 out of 100 is equivalent. Notice that it's equal. It's equivalent to 8 over 25. Okay. Here's some more. Now they're not giving us the first value. We got to work our way around. 0.55. And I don't remember the top, what order we were in. Percent decimal fraction ratio. Okay. Percent decimal fraction ratio. And my model. Okay. I should have brought that over to this page, but anyhow. So 0.55 is 55%. 0.55 is 55 out of 100. And it's 55 to 100. Alright? And then I'm going to simplify this. 5 will go into 55. 11 times 5 will go into 100. 20 times. So I could do 2 rows of 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Do another one. There's 20. There's 20 squares, and shade 11 of them. So shade this one, and this one, and this one, and you get the idea. Some of this is a little tedious, but drives home the concept. Great. So there's 11 out of 20, which is equivalent to 55 out of 100. All right. 9 out of 10 is 0.90, which is 90%, which is 90 to 100 if we're going to put it as a ratio to 100. Okay? And this one, this one's an easy one. We draw our boxes 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And we're going to shade all but one. 90%. 9 out of 10. There's 9 out of 10 shaded. Okay? This one, they're giving us the model and nothing else. So it's, let's see, 1, 2, 3, 4, 5, 6, 7 shaded. 3 not shaded, so it's a total of 10. So it's 7 out of 10 or 70 out of 100, 7 out of 10, 0.70, 70%. Okay? All right, moving right along. Exercise 5. Mr. Brown shares with his class that 70% of the students got an A. 70% got an A on the English vocab quiz. If Mr. Brown has 100 students, create a model to show how many of the students received an A on the quiz. Here's my model. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? 70% is 70 out of 100, which reduces to 7 out of 10. So I'm going to shade 7 of these. And there's my model. 7 out of 10 students got an A. What fraction of the students received an A on the quiz? What fraction? 7 out of 10. How could we represent this amount using a decimal? 0.70. How are the decimal, the fraction, and the percent all related? They're out of 100. So in order to make that true, let's do this. Up here, 70 out of 100. 0.70 out of 100. Okay. Exercise 5. Marty owns a lawn mowing service. His company, which consists of 3 employees, has 100 lawns to mow this week. I don't even like mowing one lawn. Use a 10 by 10 grid to model how the work could have been distributed between the 3 employees. Employee 1, employee 2, employee 3. This is not a problem that is going to come out with the same answer. Answers can vary on this. Depends on what you choose. Okay? I'm going to try to make it as even as possible. And I'm going to, I don't know, let's say employee 1 does 35%. As a fraction, that's 35 out of 100, or 0.35. This is 100 squares, so I'm going to shade 35 of them. I'm going to go horizontal this time. Okay. There's 30. But then I got to add 5 more. 1, 2, 3, 4, 5. So there's 35%. There's my employee number 1. There's the lawns he's got to mow. There's 35. Okay. Well, if I do 35% for employee number 2, then it'd be 35 out of 100 again, and that would also be 0.35. And that would be 10, 20, 30, plus these 5 right here to make up that row. And now this guy's got 35. So that adds up to 70. And if you check, there are still 30 lawns left. That's 30%, 30 over 100, which is 0.30. And this answers could vary, but this is how I could distribute it. And if the guy who only got 30 lawns was complaining because I pay by the lawn, to make it fair, I could rotate every week. And over a 3-week period, everybody would have all 100 lawns every 3 weeks. Color over the name with your same color you use. Okay, I just did color coding. I didn't use letters and so forth. You're all dead. All right. All right. Lesson summary. 1% is the number 1 over 100 and is written as 1%. Percentages can be used as rates. For example, 30% of a quantity means 30 out of 100 times the quantity. We can create models of percents. One example would be to shade a 10 by 10 grid. Each square in a 10 by 10 grid represents 1% or 0.001 or 1/100th. Okay. There you go. Do your problems.